So this poster here, we're testing the performance of variable rate irrigation versus constant rate irrigation for this region of Wyoming. So a little bit about variable rate irrigation and stuff like that. It's starting to become a bigger trend here in Wyoming. It's really important to start looking towards this type of irrigation in terms of saving water, saving time and labor, and growing your crops more efficiently and effectively at the same time. For example, say you got a part of your field that's more heavier in clay than the other. Well, you're going to want to apply less water right there, and being able to change your rate as you're going across that section is really, really huge. You're going to save a lot of, your crop's going to grow a lot better because it doesn't need that extra amount of water. So the objective of what this study is all about, we're trying to see how accurate the uniformity of this lateral actually is, while we're also testing to see how much wind is affecting the lateral as well. So wind can also play an effect on how uniform the overall application is. So for this study, we use 3 spans. Each span in this picture here, you got 3 zones. Each zone has 6 sprinkler heads, and you can change each zone to whatever application you want it to be. And you can change it 10 feet down the road, 20 feet down the road, or even 5. It doesn't matter. You can change it on the computer, Wi-Fi, everything you need. So what we did is we took a bunch of catch cans, we threw them out there and stuff like that, got our bunch of measurements. We used 3 different application rates. We used 50%, 80%, and 100%, which was 0.5 inches of irrigation, then 0.8 inches, and then 1 full inch. After we got our measurements taken and stuff like that, we did some mathematical equations with some different coefficient equations and all that, and we got some really, really good information. So in this graph up here, this blue line is our 0.5 inches, and then this next section here is 0.8, and then the next one was 1 full inch. This line here with the triangles is what I measured in the cups. And as you can see, going down the span, it was right up against that trend line, so it stayed really, really accurate. It held true to it. Now, in terms of wind speed, the wind speed does have an effect on how uniform it is, but on such a small level. These graphs right here, you can see that you got, your blue here is 3.5 miles an hour, your red is 4.5, and your 9 mile per hour is going to be in yellow. Now you can see that the 9 mile per hour is slightly a bit lower than the other wind speeds. And each wind speed was a different day, different measurement. So it made it more randomized and stuff like that. Now, in terms of a percentage of actual uniformity, 9 miles an hour, the higher wind speed reduced our uniformity quite a bit in comparison to the lower wind speeds. But down here in this graph, our overall percentage of our coefficient uniformity, there is very, very little difference whatsoever, not significant enough in comparison to a constant rate irrigation, which constant rate would be like, say, 1 inch across the entire field. You can't change it. Over here in this graph, we got a mean bias error. These numbers here tell us whether or not we're over applying or under applying of what we're actually measuring out and stuff like that. All these numbers here are negative. Not sure if you can see that, but what that negative number means is we're actually under applying water, so out of the irrigation, which is only millimeters. I mean, it's 1/10 of an inch, so it's not significant at all. It's hardly any difference at all, and that makes this system really reliable, really accurate, really efficient, and it's just really, really great system to use overall. That's starting to become, like I said, it's starting to see a lot more irrigation systems coming here, this part of Wyoming, which, because of our drought-like conditions, can be really, really effective in terms of water loss and being able to save water overall and saving money.
So were you testing this with a variety of crops or one particular crop?
So this only crop we specifically used in this was just barley. The kind of crop we used really wasn't that big of a difference in this kind of situation. For this specific one, we're just specifically testing the irrigation system. We could have done this over sugar beets or anything we really wanted. It happened to just work out into the barley field that we were growing. So.
And then, so for producers who might be interested in trying to do variable rate irrigation on their own places, it sounds like they don't really need to worry as much about wind speed. It does make a difference,
Yes.
but not as significantly so.
Yeah, so up to 9 miles an hour, you're relatively safe. This is an ongoing study. I should have mentioned that earlier. But this is going to continue on for the next couple of years, and hopefully we can get measurements with higher wind speeds, since our wind speeds can reach easily up to 20, 30 miles an hour here. So it'd be nice to be able to get measurements on those higher wind speed days and seeing how that affects our results. What we would predict is that obviously if we get up to 20, 30 miles an hour, you're going to probably start to lose a little bit more uniformity and probably apply less water than you would normally would. How much? Hard to say. We'd have to wait for next year's results and stuff like that.
And then the last question I had is, you mentioned that one of the reasons we might want to apply variable rate was that, to account for soil difference and clay holding more moisture, things like that. Do producers really need detailed understanding of their soil types to effectively use variable rate irrigation then? Or?
Generally, it would be important to know what kind of soil you're growing your crops on in general. Now, you can go through different organizations and companies to get their supervisors, their crop surveyors to come out and do all that work for you and say what kind of soil types you guys got, or what field is sucking more water through than the other, and what's infiltrating faster and what's not infiltrating fast. So it is important to understand that. Now, you could look at your field in general and see, well, this stuff looks really, really dry, but that stuff probably doesn't need nearly as much water, in terms of just looking at the plant itself and be like, well, I'll put a little bit more on here. But if you just take that extra step, though, go through the process of understanding what your field layout is and what section and stuff it is, it'll be a lot more efficient that way.